This video is to show you how you would carry out the optional extra credit assignment, this one that I handed out in class called Residue Designs. So first I want to explain how they come up with these little artistic designs here, and then give you a little bit of the math that's involved in coming up with these charts. First of all, given the table here, let's see how you would draw the design. So in the table, 1 is mapped to 2, so you draw a segment from 1 to 2. 2 maps to 4, so a segment goes from 2 to 4. 3 maps to 6, that's that segment, and so forth. So 4 to 1, 5 to 3, and 6 to 5. Once those segments are all drawn, then the shading that was done here is just artistic license. So there was nothing compelling about what sections were chosen to be shaded. Same song, second verse over here. So a segment connects 1 to 3, 2 to 6, 3 to 2, 4 to 5, and so forth. So you'll see those segments there, and then again the shading was just chosen so that it would look nice. Now the next question is, where did this table of numbers come from? It's actually not as random as it looks. If you look at the beginning pairs, 1 to 2, 2 to 4, 3 to 6, you might think there seems to be a multiplication by 2. And in fact, that's exactly what's happening. You're multiplying the input on the top row by 2. However, the output is not just the multiple. It is the remainder after you divide, in this case, by 7. So if we think about, well, let's think about the bigger number here. If you multiply 6 by 2, you get 12. But if you then divide 12 by 7, 7 would go in one time, and you'd have a remainder of 5. So that's where this 5 comes from. If you multiply 5 times 2, you get 10. But if you then divide by 7, your remainder is 3, and so forth. So that's where these numbers on the bottom row come from. Now, even these smaller numbers are really the remainders after you divide by 7. If you think about multiplying 2 times 3, you get 6. Well, 7 divides into 6 0 times with a remainder of 6. So these truly are all the remainders when you divide by 7. The mathematical term for that is to say that these are the results of multiplying by 2 mod 7. So that's just a shorthand way of saying what's left after you take out however many multiples of 7 you can. The same thing's happening over here, but as you can tell from the opening entries, 1 goes to 3, 2 goes to 6. This time we're multiplying by 3, but then when those products are more than 7, we just report the remainder after dividing by 7. So 3 times 3 is 9, the remainder is 2. 3 times 4 is 12, the remainder is 5, and so forth. So that's where these numbers are coming from. Now, you can use other mods. In fact, in the bottom half of this page, you'll see that this time the circle has been divided into 10 sections. And so maybe comparing with the top here, you can kind of guess. In the top one, we had 6 sections, and we were looking at the remainders mod 7. Here we are looking at the remainders after you divide by 11. Okay, so that's where these numbers are coming from. Okay, just to, let's do a quick one here. These are the result of multiplying by 2. Okay, so 3 times 2 is 6, 4 times 2 is 8. 9 times 2 would be 18. 11 goes into 18 one time, and the remainder is 7, and so on. From these numbers, of course, from this table, you would make the design just like we discussed above. So you see that 1 goes to 2, so you would use a straight edge, make a nice straight segment, connect 1 to 2, and then connect 2 to 4 again using your straight edge so that you get nice straight segments. And then after you're done making all the segments, this time there'll be 10 segments, you can decide where to shade just to make it look nice. Okay, so this one, sometimes we give these a little ordered pair to tell us what the design is based on. So in this case it's mod 11 and the multiplier is 2. So we would say this design is an 11, 2 design. And I'll let you identify where these numbers came from. It's still mod 11. Okay, but I think you'll be able to see what the multiplier is here. On the back of this sheet, well, mine isn't on the back, but yours is. It has a little bit more discussion about this kind of arithmetic we're doing, where we're just focusing on the remainders after using various divisors. At the bottom half of that page, there's a whole multiplication table for mod 11. So you're going to do a complete summary of the results when you multiply, but only look at the possible remainders mod 11. You'll notice that we don't include the possibility of a remainder of 0. That's more subtle reasoning that we'll probably come back to when we have the algebra course in a couple months. On the third page, there's a little bit more discussion about the multiplication table, and then a few more examples of various mods that will give you a different kind of a design. Remember, this first number tells you the mod, and the second number tells you the multiplier. And so, for example, in this one here, to get the table that would tell you how to connect these dots here, since we're in mod 5, the possible remainders are just 1, 2, 3, and 4. Okay, and then you want to multiply by 4. So 1 times 4 is 4. 2 times 4 is 8, but remember, we want the remainder when you divide by 5, so it'd actually be a 3, and so forth. So I'll let you finish doing these. At the bottom of this third page, they ask you to do an 11-4 design, and then they talk about how it's going to turn out to be identical to a previous design you did and why. And that leads me to the last page that I want you to work on, which is this supplemental page that I gave you that says Residue Designs Mod 11. On this page, I give you enough circles so that you can look back at your Mod 11 multiplication chart from page 2. Let me just pull that up. And from this multiplication table, you can decide which columns are going to potentially give you new designs that you haven't seen yet. Okay, and record those on this extra page. Again, this time you get to put your numbers in here. You know, put your 1, 2, 3 up to 10 as it is on the first page, and make your table, and then do the segments, shade as you want, just so that we have then a complete set of the different designs that arise from multiplication mod 11. Okay, so those 4 pages are the ones that I want you to complete in order to do this extra credit project. There's 2 more pages that are just kind of for your interest. These are some residue designs that are pretty cool. They're higher mods, and so they would take more time to do. In fact, these ones at the bottom are such high mods that they didn't even shade. Mod 65, multiplier of 3, mod 65, multiplier of 2. So they're pretty cool. And the very last page that is just for your interest, that you don't have to do anything with, is just this this page here, where they actually give you a template if you wanted to do the Mod 65 multiplier 2 design. So that is the complete introduction. This will be due on December 11th, which is our final exam day. It's our very last day that we meet. I will put up an assignment on Elms where you can scan your work and submit it on Elms. If you wanted, though, you could also just bring the hard copy to class on the 11th, so I'll accept it either way. Whatever's easier for you. And I hope that if you're interested in this, again, you can also just do part of it if you don't want to do the whole thing, or you don't have time to do the whole thing. I will give part credit if you just do a portion of it. So I hope that maybe you'll enjoy just playing around with this a little bit and see how these remainders can lead to some interesting patterns. Have fun.